found a bit of time to make up a kit, so I'm going to look at this thing. This is some kind of lighting effect. I'm not really sure what. I haven't seen this one before, but let's make it and see what it does. So we have a heart-shaped PCB. You can see there's slots around the outside for LEDs to go into. Got a bag of LEDs, a few assorted resistors, 3 of the same type there, 47k I think, 10k, 220 ohms is that, and 100k I think. We have a tiny switch, variable reset trimmer pot, transistor, capacitor. Let's have a look, which one is this? S8050, so common NPN type. And then finally we have the chip LM358, which is a dual op amp. Okay, so let's get going. I'll put the resistors in first. The silk screen's quite nice on here. It's got the values of the resistors, so it's going to be really easy to get them in. So 3 47Ks. So it's a bright morning in February, and the sun's out. I was woken by the birds early this morning, so I thought I would do some electronics before anybody else wakes up in the house. These are not my good ones. Okay, that's better. Okay, so 100K. Oh, that's 22 ohms. I was not quite right. Not 220, but 20. So So the red is 2, so we've got 2, 2, and then the black ring is the multiplier, which is no extra zeros here. And then this is a 10k, and that goes at the top above the 47k's. Okay, so that's all the resistors in. I think I might put the chip in next. So we need to make sure that the alignment marker, you've got the little cutout at the top that marks the top of the chip, and that matches the silk screen here. So that's good. It's hard to go wrong. And they do say to always, when handling chips, to wear a anti-static wrist strap so that you're grounded. But I must admit that I have rarely ever done that during my entire life. And I think I've only lost one chip. So the advice seems a bit much to me, but I don't know. And this isn't a LM358 isn't a CMOS chip, so it shouldn't be very susceptible to static electricity. But I'm sure that chip designers think about static sensitivity, and I've seen a lot of chips that have got protection diodes and so on actually built in to the inputs and outputs of the chip. Check my soldering there. It looks alright. Okay, so the chip's in place. I could put in the transistor, which again is nicely marked on the silk screen, so no danger of putting it in the wrong way. It's not taking solder very well. Okay. Middle one doesn't look too clever. So you shouldn't overstress silicon components by keeping the heat on them too long, but hopefully that was all right. So we've got the trimmer pot goes in over here. These components are quite nice. Once you get them in, the tension in the legs holds them in quite well. So they're quite easy to solder in. See that? That's very firmly stuck in now. And we'll put the switch in also. The switch isn't holding itself in very well, but let's see if we can tack that into place. Oops, let's bridge two of those together. Get my desolder pump in. This I bought absolutely decades ago from RS Components, but it's really nice actually. So you just cock it like so, and then you press the button to release the catch, and the tips are replaceable. So I've been using this for a long time. You need several hands for this job when you're soldering, desoldering. No, didn't do it. Let's get some white tack to hold it into place. No, that's not at all good. Let's have another go. So we've got one pin that's not soldered here. Yeah, that's a bit better. Let's just put a little bit more on there. Yep, I think we're right. So we got a capacitor here, so electrolytic type. Let's make sure we get the negative band on the proper marker on the circuit board. Again, these electrolytic capacitors, you're not supposed to really stress them a lot in terms of heat. So best to get in and out as quick as possible. It doesn't look very good though. Some of these pads are not taking the solder very well, I must say. All there is left to do now is add these LEDs. But I think I might test them first, because I've had bad experiences before where, you know, I've soldered in the LEDs only to find that some of them are not working. So I'll do a quick test. Okay, so I've set up my bench power supply to current limit at 15 milliamps, and so if we look at these LEDs, so the way that I normally know which is positive is the long leg is the positive, and you can often tell looking through the case to see which is the anode and the cathode. But the other official way is there's a flat spot on one side of the case. See, it's very flat on that side, marking the cathode. Let's just check these LEDs. So that's the negative, that's the positive, and they're red LEDs. Okay, one more. There we are. So they're all good. So they're all marked on the board, showing which way the current flows through the diode, so just have to install them. There we are, all the LEDs plugged in. There are actually 3 still left over here, so they supplied some spares. Okay, so I've trimmed all of the leads off now, and I did inspect them with the magnifying glass a bit, and I've put some leads on so I can put some power in. So it says DC 4 to 6 volts. So we'll get the power supply in. Select 4 volts. I've got a current limit of 80 milliamps. It's not a bad idea to have a current limit when you first switch something on, because it limits the amount of heat and damage if you've got something short-circuited. There we are. So it's just sort of pulsing the red LEDs. Try turning the trimmer, see what happens. Alright, so it's just changing the pulse length basically, so it's just like a little dim pulse now. I quite liked it at the other end. I think that might be permanently staying on now, so let's back that off a little bit. No, a bit more. There we are. So there we are, little kit, heart kit, not done quite in time for Valentine's this year. But yes, quite a nice easy kit to make. I think it was about 80 pence, so less than a British pound. So good fun for the money.